Hi everyone, my name is Christopher Penny, a support engineer here at CD at EPCA. Today I'm going to be covering some brief information on Y plus values, including how to mesh prism layers for effective wall Y plus values. The law of the wall explains that the average velocity of a turbulent flow at some point is proportional to the logarithm of the distance from that point to the wall. So basically velocity depends on the distance to the wall. Y plus is the wall coordinate. Distance y to the wall, which is made dimensionless due to the friction velocity and kinematic viscosity. This shows a graph of law of the wall comparing y plus with dimensionless velocity. Here you can see that the y plus values from 1 to 5 actually solve out for the boundary layer, while values from 5 to 20 fall within a logarithmic blended region. Values from 30 and above model or estimate the boundary layer. So if possible, try to keep your wall y plus values from falling in the range of 5 to 20. Okay, so now I'm going to go through a few examples of how to mesh your prism layers so that you can get the wall y plus values that you're looking for. For this case that we're working with, we have a duct with an inlet and an outlet. The inlet has velocity coming in at about 10 meters a second. I have 4 different windows. The first one is showing kind of the velocity gradient leading up to the wall. The second one is showing the wall y plus values. The third one is showing the mesh of the prism layers leading up to the bulk mesh. So in each one of these cases, what I'm going to do is change a few different parameters and show how it affects the wall y plus values. The first thing I'm going to change is the thickness. The second set of things that I'm going to change is the number of prism layers. And the third thing I'm going to look at is how the stretching in between the prism layers changes the wall y plus values. So for this first case that you're looking at, what we're looking at right now is a case where everything is set up the way it's supposed to be. You can see the velocity gradient, you can see the wall y plus values fall between 1 and 5. In this case, the highest they reach is 1.46. There's good growth out into the bulk of the mesh, so the outermost prism layer isn't so thin that the aspect ratio between it and the bulk mesh is enormous, which can affect residuals, as we'll see. The residuals converge. So the first thing that we're going to change is the thickness. So I'm going to change my thickness from 0.005. I'm going to change it to be 10 times the thickness of my individual bulk cell size. So when I do that, I can see that it expands out beyond what it really should, and it kind of splits up the cells so that the change in size in between each cell is not uniform. So that's not exactly ideal. The other thing that we can see when we run this is that the wall y plus values are going to change and the velocity gradient will change as well. Now I do have to come into my models and switch out low y plus treatment to all y plus, so that it'll deal with the higher y plus values better. I'm going to mesh this and run it. So now you can see that the velocity gradient is pretty much non-existent. There's not many velocity vectors leading up to the wall. You can see that the wall y plus values fall between 0 and 11.5, which falls right into the blended region. The mesh does grow out into the bulk of the mesh, but it does change the cell size from big to small and back to small again, and the residuals do converge. So in this particular case, you can see that the wall y plus values are not what we want. So I'm going to change this to be much thinner than it actually needs to be and show what happens. I'm going to change my model so that I'm modeling low wall y plus values. Mesh this, clear the solution, and run. Okay, so looking through the screens, you can see that there's not much of a velocity gradient leading up to the wall because most of it's been cut out in here. In this window, you can see that the wall y plus values do fall within a very good range, 0 to 0.038, and you can see that in here, the mesh. This is obviously not ideal because the outermost prism layer thickness is very, very small compared to the bulk mesh. The other thing that you can see is the residuals do not converge. So obviously this is not an ideal case. Okay, and starting from our ideal case, what I'm going to do now is add 2 mini prism layers in. So if I come into here and add 15 in, mesh this, and then run it. Now when looking at this, I have very good velocity gradient coming up to the wall. This is by far the best we've seen. The wall y plus values fall between 0 and 0.19. The growth from the wall out into the bulk mesh is very good, and the residuals converge. The only problem with this is that I added more cells and I had to wait longer for this thing to run out to 250 iterations. So if you don't have to add more of these cells in there, because for here we're falling in between 0 and 0.19 for our y plus values, we can reach all the way up to 5 and still actually be solving out for that boundary layer. So this is kind of not necessary. So now I'm going to look at a case where instead of having 15 prism layers, I'm going to have 2. So I'm going to have too few, and my y plus values are going to go up. So I'm going to clear the solution, mesh this, and run it. Okay, so now in here you can see that there's not much of a velocity gradient leading up to the wall. Our y plus goes all the way out to 39, which goes in the blended region and actually even beyond that. The prism layers leading out to the bulk mesh looks good, and the residuals go down. Obviously, we do not want this primarily for the y plus values that we get from this. So the last parameter that I'm going to work with is the stretching in between the prism layers. So I'm going to change this back to our ideal case. It's where we had 10 prism layers, and I'm going to come up to our prism layer stretching, and by default this is set to 1.5. I'm going to change this so that the stretching in between them is only 1. So in other words, there's absolutely no stretching in between any of the prism layers. And I'm going to go ahead and mesh this and clear the solution. Okay, so you can see that there's virtually no gradient. The y plus values lead up all the way to 12.6. There is not much of a growth out into the bulk mesh, and the residuals do converge. Obviously this would not be ideal just because of wall y plus values. Now as the last case of this, I'm going to change the stretching so that it's 3 in between the cells. So in other words, the first cell compared to the second cell is 3 times larger than that first one, leading out away from the wall. So I'm going to go ahead and clear the solution, mesh it, and I have to come down into models, switch out my models to be low y plus, and run this. Okay, so now you can see that there's not much of a velocity gradient. The wall y plus values are good. The maximum leads up to basically 0.02. The growth out into the bulk of the mesh is not really that great, just because every prism layer kind of expands out so much because we set that stretching factor up so high, and the result of that is the residuals did not converge. So in that last simulation that we're looking at, the y plus values in the prism layers didn't exactly matter because it doesn't really change the outcome for that particular simulation. So in some simulations you don't particularly care about y plus values in prism layers, but in a case like this where we have an airfoil with 20 degrees angle of attack, that can dramatically change your solution. As you can see on the scene here on the left, we have a low y plus value. There's 8 prism layers applied, and on the case on the right, the only thing that I've really changed is that there's 2 prism layers. So you can see how it completely changes your boundary layer separation, your entire solution. So for a case like this, your y plus values and prism layers are very important. And just for verification, I've changed the scene to show the wall y plus value. So you can see here on the left that the y plus values reach up to 3.5 on the low simulation, and on the high y plus simulation they reach all the way up to 78. So in summary, with simulations where y plus values matter, make sure that they fall between 1 and 5. And also ensure that the growth and aspect ratio in between cells are not too large.